into applications. So applications of concavity, inflection points, and those kind of things. As the first application is a graphical case. So given a graph. So suppose that you're given a graph of the consumer price index. All right. So graph I is the consumer price index for a small economy. I suppose that time 0 is 2008. The function is graphed from 0 to 10, which means 2008 is when it starts. 10 years later, it stopped at 2018. So the information is just from 2008 to 2018. All right, and then they plotted 3 points on the graph, which are important 3 points. All right, so the first question, is the first derivative positive or negative over the 10-year period, and interpret? So over that 10-year interval, are my slopes positive or my slopes negative? Well, if you look here, it's always increasing. So the first derivative is always positive. Right, the slopes are all positive, which means the consumer price index is increasing the entire time from 2008 to 2018. All right, so for this economy, over the 10-year period that we were given, between 2008 and 2018, the consumer price index increased over that entire time. All right, what's the inflection point of the 10-year period? All right, so I'm going to go look up here, and so you'll notice it's subtle, but you should notice that this first piece is the slight, but it is concave up. And then at this moment, it's switched. Now look and see, again, subtle. A lot of times concavity switches, and it's very subtle like this, especially in real life examples. But it did switch. This is concave up. At this moment, it switched to concave down. So this is my inflection. All right, so the inflection point is at 5,150. So that means at 2013, right, that would be 5 years after 2008, the consumer price index was 150, and this is the inflection. All right, so that's it. That's all it asked for in that question. Now it asks for, well, why would be finding the inflection point important? Right? Why knowing where concavity switches be important? Well, the reason why, if you've ever heard of the law of diminishing returns, this kind of plays into that law a little bit. If you've taken an economics class and they've talked about that. This isn't exactly the law of diminishing returns, but it's the same sort of idea. All right. Over the first 5 years, right, this is to 2013, concave up means I'm increasing at faster rates. So the consumer price index is moving up, and it's moving up at faster and faster rates. Right? It was slower here than it was here. Right? The slope was smaller here than it was here. At the inflection point, at 2000 point, this is when the consumer price index is increasing at its fastest rates over the 10 years. So 2013 was when it was moving up the fastest. It has the biggest slope at that time. After that moment, we switched to concave. It still increases, but at slower and slower rates. So it's still moving up, but it's moving up slower. So it's not moving as fast. Again, eventually it will taper off and reach its peak, and it won't move up anymore. We weren't given that information, but it will slow down to the point where it stops moving up, and it might switch and move down. All right, but at this graph, it just means the second half of the 10-year period, it's still moving up, but it's moving up at slower and slower rate. So you can put that in your own words, but the inflection point, so at the inflection point, which is the year 2013, the consumer price index is moving up at the fastest rate of growth over the 10-year period. All right, it's 2013 is when it's moving the fastest. It's moving faster than it was in 2008. It's moving faster than it was in 2010. It's moving faster than it was in 2017 than it was in 2018. All right, 2013 is the fastest growth year. So again, however you want to put that in, after 2013, the consumer price index slows down. Now it's still growing, it's just slowing down. It's growing at slower rates. Alright, so that's a graphical example. Alright, pick up the next example in the next video.